Good morning. This is your stats sensei, Mr. Spensei, and we're going to be looking at a problem that deals with the normal and also deals with the distribution of means. This is from 2004B. It's a question 3. Trains carry bauxite ore from a mine in Canada to an aluminum process plant in northern New York State in hopper cars. Filling equipment is used to load ore into the hopper cars. When functioning properly, the actual weight of ore into each car by the filling equipment at the mine are approximately normally distributed. That's important. Generally speaking, if they tell you it's normally distributed, you're working with a normal curve with a mean of 70 tons and a standard deviation of 0.9. So our standard deviation is 0.9. If the filling equipment is functioning properly, what's the probability that the weight of the ore in a randomly selected car will be 70.7 tons or more? So first off, they're telling us our distribution is normal. We're going to write that down. Our mean equals 70, and our standard deviation is 0.90. And we're looking for the probability that a single car X is greater than 70.7, where X is the weight, is the car weight or train car weight. All right, that's what we're looking for. Let's go ahead and draw a picture of this. This will give us some guidance. So we have a mean of 70. We want 70.7, and this goes to infinity, and our standard deviation is 0.9. So when I look at this, I know this car is going to be less than 1 standard deviation. So Z equals X minus mu over sigma. And I'm going to want the probability that Z is greater than, because we want to find out more extreme, 70.7 minus 70 over our standard deviation of 0.90. It's only a single car, so I don't have to divide by the square root of 1, because that doesn't do me much good. So we have our work shown here, but we're going to go ahead and run this thing. So we're stat test, and this best, even though you can do norm CDF as Z test, will give me my Z score, which I need. So my mean is 70. My standard deviation is 0.9. My X bar is 70.7, and I'm going to use the sample size is 1 because it's a probability of 1 car, and we calculate. And we get the probability that Z is greater than probability that Z is greater than 0.7777 equals 0.2183. So basically about 22% of the time that happens, and that's not particularly rare. Basically, we call it rare if it happens less than 5% of the time. So not particularly rare. So suppose that the weight of the ore car in a randomly selected car in A, so this tells me 1 car, is 70.7 tons. Would that fact make you suspect the loading mechanism is overfilling the cars? And the answer is no. A car that weighs 70.7 tons or more would be expected to occur about 21.8% of the time, and that is not unusual. All right, so not very unusual. Part C, going like Moses. If the filling equipment is functioning properly, what is the probability that a randomly sample of 10 cars will have a mean or weight of 70.7? Ooh, we changed things here. So I should go back up here, and we said X is greater than 70. Here we're looking 70.7, I'm sorry, greater than 70.7. Well, we've kept things, this is the same. We're talking about a mean and a random sample of 10. So N equals 10, and here we're working with an X bar. So things have changed a little bit, all right? Now our diagram is actually pretty much the same, but let's work this out. So it's normal. Our mean is still 70. But our standard deviation is now different. We're now working with the standard deviation of X bar, which is going to be the standard deviation divided by the square root of N, which in this case is 0.9 over the square root of 10. All right. And we have an X bar equal to 70.7. Notice this has to be an X bar, so we want the probability that X bar is greater than 70.7, where X bar equals the mean car weight of 10 cars. Our diagram is a lot the same. It's 70 and 70.7, but our standard deviation is now 0.9 divided by the square root of 10. All right. So in our formula, we're going to be working with Z equals X bar minus mu over the standard deviation divided by the square root of 10. So we want the probability that Z is greater than 70.7 minus 70 over the standard deviation of 0.9 divided by the square root of 10. So second vars, stat test, Z test, 70, standard deviation is 0.9, X bar is 70.7, but now our sample size is no longer 1, it's 10. We press calculate, and we want the probability that Z is greater than 2.4595, which equals 0.0069. All right. So Z equals 2.459, and we get a probability of 0.0069. That's pretty rare. All right. That's less than 1%. So that's pretty extreme. Based on your answer in part C, if a random sample of 10 cars had a mean or weight of 70.7 tons, would you suspect the loading mechanism was overfilling the cars? Justify your response. Yes, I would believe the cars are being overfilled because there is a less than 1% chance of 10 cars weighing 10 cars, excuse me, not weighing, having an average weight of 70.7 tons or more. All right. So yes, I would believe the cars are being overfilled because there's less than a 1% chance of 10 cars having an average weight of 70.7 tons or more. That is very rare. Right? That's unusual. So I hope that helped out a whole lot. A lot of times, just so you know, that they'll combine part C and D in the same question and part A and B in the same question. And you need to make sure that you not only show your mathematical work, but you give your explanation to the answer. Here they broke it out, which is kind of nice. You're less likely to leave something off. But if they ask you a question, make sure you don't just provide the math, but you provide a written answer to the question. All right. Thank you for watching, and I'll see you on the next one.